They're coming. How are you guys?
Hi, hi.
Hi, hi.
Nice
Thank
to have
you.
you here. Good luck.
Thank you. Is it visible? Ходите из десна страна, ще видим лаптоп.
Hello, everyone. Thank you for coming. I know it's late, everyone is tired, but I assure you we'll keep this interesting. So today we are going to talk about migration from SQL tables to graph databases using agents. And I'm Dino Duranovic. I come from AppCont, and this is Ante Javor from memgraph. You might be confused, where do AppCont and memgraph come together? But we are actually working on a lot of AI projects together, and we came to the idea that we do the presentation together. So you might have heard about graph databases. They are pretty popular right now. And everyone says that they are good for the AI. Today you're going to find out why. First, I would like to start by refreshing our memory on what the graphs actually are. We meet with graphs every day in real world. For example, today I came from Graz, Austria, to Zagreb, and from Zagreb to Zadar. As you can see, this shows us a small graph, but it tells us something. It tells us that there is a connection between these cities. And another real-world example is, for example, me and Ante standing on this stage and talking about the talk from tables to graphs, and all you people sitting here. What does this graph show us is connection between you and us. It wouldn't have happened if there wasn't this talk. But what is graph in a technical sense of the way? In a graph database, the graph is a data structure that shows us a relationship between the nodes. And every graph has to have following properties. Nodes, as shown on the picture, then every node has to have a label. In our case, in this small case, person and talk label. Every node has to have a relationship to another node. And for example, in our case, two top nodes have a relationship with the talk node. Relationship is called speaks at, and the bottom nodes, you guys are attending this talk. And the last optional part of the graph is a property. For example, in our case, a person has a name and a company that they come from, and talk has a name and the stage that is performed on. Now that we all know what the graphs are and are all on the same page, we need to store these graphs somewhere, right? And for that, we need the graph databases. This is where my colleague comes in and tells you more about it.
Hi, so I'm Ante. I come from memgraph. We build a graph database. Essentially, we deal everything really regarding to the graph, whether you have to do some compute on the graph, store the graph, visualize the graph, run some algorithm like a PageRank, etc. We essentially build tools for that, and we implement the algorithms. One of the key products that we do is a graph database called memgraph. It's an in-memory storage. It supports async transactions, and due to the nature of being in memory, it's quite fast, so people tend to use it in the very low latency applications, like recommendation system, knowledge graphs, AI system, etc. So essentially, we kind of deal with the storage of a graph model that Dino just described. One of the things that we were discussing is how this whole AI that you are listening all day about is interacting with graph. And we had some experiences before, but I will talk about this a bit later. And essentially, like, how can we leverage LLMs and AI tools in context of a graph and graph storage? And the idea is essentially to have modeled hypothetical model of a graph driven by neural network, and I will kind of explain how this works and why we did it. So if I now ask you whoever modeled the graph here, I would probably see 1 or 2 hands, maybe, who modeled the graph before. OK, I can see a few hands. But I guess most of you have SQL databases and SQL models running in production, and you're kind of used to the SQL world and less to the graph world. And the idea is how to move you from your data model to the graph model, and I will explain why would you even do it. But the idea is how to bridge that gap. So essentially what the problem is. The problem is for you to get the graph, you need to understand how to graph theory works in a concept. You need to understand how to model that graph. You need to understand the cipher. And you need to have that modeling expertise to not mess things up. And also, the databases can operate in a different way. For example, memgraph is an in-memory database. It brings some of specific flavors to typical in-memory storage. And the idea of hypothetical graph model is, what if we can bring those problems and solve it from you with some automatic system? And this is where shortly HyGM, or hypothetical graph model, kind of kicks in. The idea is to have agentic model that essentially models the graph for you based on the SQL data. It currently works only with MySQL, but we plan to expand that to Postgres and the rest of the SQL flavors. So what it does is essentially go over your schema and tries to create hypothetical graph model. I will explain this in a bit more details. And if you go to this link, memgraph AI toolkit, in the integrations, there will be implementation of this concrete agent. And we are still working on it. It's a project that we work on currently. So there are a few quirks, but you will understand. So this is the very simplified version of what it does. I will kind of walk you through the steps. So the first is schema and the data. Essentially, we go over your SQL database and look for the tables and the data that is related to a potential graph model. And then we model it to a HyGM type of format, pass that to the LLM. LLM spits out the initial graph model via the structured outputs. So that graph model is just like envisioned by LLM type of thing. And then we have 2 types of feedback. One is validation feedback, which essentially kind of checks, are your tables in SQL covered by the graph model? Do you have the nodes and relationships? Or you can give NLP feedback. For example, I don't want this node. I want to change the name of this relationship, etc. It's like your body in modeling the graph. Once that feedback loop is being done, you then go and take that final graph model, which is a hypothetical model, and you can use it to, for example, migrate data to memgraph. You don't need to necessarily do it, but you can do it. So the idea is to bring the gap from how do I move this data and this model to a graph model to just do it in a few seconds. Just to give you the brief example how these structures work. So essentially, when we analyze your data, we essentially go through your tables, detect what entity tables are, detect what view tables are, detect what join tables are. We assume what potential relationship could be, of course, and we kind of take just a small sample of data so the LLM understands how to model that graph, like what data is inside. And once we get that model, so we have like nodes, edges, nodes indexes, edges indexes, constraint. So I didn't even mention that obviously you need to also model the indexes and constraints, but this is also part of that process. Ideally, you would also want to model like embeddings and everything that goes into the graph that you probably need. Going one level deeper, so each node, as Dino had said, has labels, properties, but we also have a source node. This is quite important because if you're modeling the data and changing the graph model, you still want to have the connection back to your relational database. So if you, for example, change some label, that has table counts, for example, you want to keep track that you still have connections to that same table. So now you will see a video that essentially highlights the migration process. In this short clip, you will see me running that agent. And in the first try, we are going to run it in the automatic mode, which essentially means that LLM will model the graph, and then we'll do migration without human doing anything. So I basically run the agent. We do some validations. And we're going to select automatic mode, which means there are just basic feedback loops in terms of LLM. And it's AI-powered mode. So now what is happening is we took your schema from SQL, and with LLM, we are trying to generate the graph model. It takes some time, obviously, for LLM to generate the model. But after it is completed, we got validation failed, which means, as you know, LLMs are not super deterministic system. They fail. They produce wrong outputs. So we need to do validation. And then we are retrying with validation error in context. So for example, we said, oh, you have missed this property. Oh, you have missed this table, or something like that. And then we are trying to generate a better model. And now it is regenerating the model again. And now it succeeded. And we got some graph model that fits initial validation process, and we are migrating the data to memgraph in a graph structure. And it passed. There are a few warnings there and few issues, but this is kind of the idea, is to have your SQL data in memgraph in a couple of seconds. I will now go to another example, which is the same agent running, but this time in interactive mode, which means that you as a person can influence the model that is being generated from your database. So now you will see we started in the interactive mode. LLM is generating the initial graph model that is interesting to us. And we will provide some type of feedback back to that model. And the idea is to have this in a visual interface. At the moment, it is just a console interface, but the idea is to visualize how the graph is changing, so you have also the visual experience of that graph. You will now see when the LLM model is generated, you will see a bunch of constraints, indexes, nodes, and relationships that I will scroll through now. And this is essentially what's currently modeled in that graph. And now we have an option to modify that graph. And for example, we are going to change relationship label from acted-in to acted-in or something like that. And we essentially are modeling the graph via NLP and just saying what we want. And this graph model, this hypothetical graph model, is connected to your SQL data. So we can do a migration after the change. Now, the process is going into validation. We have some errors. Now, the new validation will pass, and then we'll get the results out back. What we get out is a graph model. This is from MySQL Sakila dataset. I think MySQL uses this as a kind of basic example of some dataset. But what is important here is what you see, we got like in a few minutes, even a few seconds. And you can see that X-in, we have changed that relationship type next to the blue node in the upper corner. What you see on this slide is essentially a memgraph lab, which is a visual interface to the memgraph graph that memgraph is stored in the engine. And obviously, via the NLP feedback we provided, we can change this graph. Now we come to the part where why would you want to move your SQL schema to a graph database? And a lot of people think that we are trying to replace a SQL database with graph, and this is not true. So what we want to do is provide a unique product that can offer you to solve a different type of problems. What we noticed recently is how the whole AI domain is rising, and people have problems with context. and how to solve different problems with LLMs, a lot of companies started building something called knowledge graphs. What a knowledge graph is essentially, you take a bunch of your organizational data, your operational data, and you kind of mix it in one single graph that essentially represents your company. It's a kind of like a second brain type of thing, where you have all hard knowledge built into the graph. The most famous example here is the Google Knowledge Graph project. They built it like, I think, 10 years ago. But now it's getting even more and more relevant because the whole LLM type of thing, because it provides the hard knowledge that is built in the graph. The another use case that we are seeing a lot is a GraphML, where they use it to feed the neural nets and train them on certain patterns. It is not just used for a drug discovery. It's used, for example, if you have a recommendation system, you release a new product, and then you kind of want to understand how that product fit in a graph into the recommendation system. And then, based on the features of that product, you're trying to do a node prediction and link prediction to see how it will fit in your recommendation system. And the third and maybe most popular thing is a GraphRAG thing, and Dino will share more about that.
Thank you, Ante. So I'm pretty sure that everyone here used LLMs at some point for developing, for writing a better email or something. And you might have noticed that LLMs struggle with the structural reasoning, and they often lose the context. For example, they forget what you asked 5 questions ago, or what information you provided. This is where the GraphRAG, or retrieval augmented generation, comes in handy, together with a knowledge graph and graph databases. So basically, this is a small example of how the RAG pipeline looks like. So you have a question, and you have your business data stored in the graph database. And when you ask a LLM a question, you first query the data from the database, and you get the similar results, similar to your question, from the graph database. And you, together with your question, you provide this context to the LLM, and LLM then can structure a better answer for you and know some things that it wasn't trained on. When I first started working with the LLMs, and I had to do the pipeline with the business data, my initial thought was, let's fine-tune the model with the data. But of course, after some research, I found out that this is very difficult and money and time-consuming. And then we came to the RAGs. And I'm pretty sure that for every business, most of the business cases, the GraphRAGs are just as good option as fine-tuning the model. And if you wish to find out more about this topic, we have a workshop tomorrow from 12 to at 12:15. You will learn how to build the graph pipelines in just 20 minutes or something, and you will learn how to work with the graph database and memgraph and perform a vector search and get the structured output from LLMs. Please make sure to reserve your spot, because the space is limited. And if you wish to connect with us, you can meet us at the booth. And thank you.